Hi everybody. Um, Today we're following the following lesson. This is the lesson of free fall. Now, what is free fall? We have the certain definition here, which is which is the motion of an object falling in a gravitational field. Now, um, such as near the surface of Earth or other celestial objects of planetary size. Let's assume the body is falling in a straight line perpendicular to the surface, so its motion is one-dimensional. Now, here on Earth, we have a gravitational field of 9.8 meters per second square. Now, let's imagine you're in the playground and throw the ball up, and the following happens during certain points in time. First things, you throw up the ball, this is point 1, then the ball goes down, is point 2, then for a really brief time, it just stays still, which would be point 3, and then it continues moving, this time horizontally. This is horizontally, since we know first we were vertically, all right? Vertically up and down. Now I want you to pause this video and try to solve the following questions. In what point do you get free fall? Is it in point 1, point 2, or point 4? This is actually point 4. Or is it in all of the points? Or when, right? When do we get free fall? And now the second question asks, does the force remain constant or it changes? Is it changing, guys? I want you to pause the video and try to solve this, and then I'll see you back. Thank you so much, guys. I'm glad to have you guys back. Now, let's go with the first question. In what points do you get free fall? Now, based on the definition that we heard earlier, you would get free fall. You would get free fall at point 1 and point 2 only. Okay, 1 and 2. Now, why? This is because in set points, gravity or otherwise known as gravitational acceleration is taking action, right, guys? Which we said gravitational acceleration for Earth is what, guys? For Earth is 9.8 meters per second square, right, guys? Square. Okay. Now, does the force remain constant or it changes? This is a great question. So, in order to find out if the force changes or remains constant, we have to have this into account. The second law of Newton. Okay, so we have the second Newton law, which would be force equals mass times acceleration. In this case, A is gravity. Okay, so let's see if A remains constant and m equals mass also remains constant, then so will F, or the force. Okay, now so will the force. Okay, so the answer would be Yes, it remains constant. But why? Okay, so let's remember here. Now, why does the mass remain constant? Because we don't suddenly have something, like with more mass, or we don't have like more atoms in the basketball while we're doing this. Like there's no increase in the amount of atoms per space. We don't have like there's no change in mass, okay? Because the basketball remains the same throughout. So that explains why mass remains constant. Now, why does the acceleration remain constant? Now, um, g, g is a constant. Why, guys? Was found to be a constant thanks to what, guys? Thanks to so it was thanks to many scientists. First, Galileo found that gravity is a constant and he found that gravity is a constant many and that if you throw two objects, okay, from the same height, you will get the same result even if one is heavier heavier than the other. Now, how did he find this out? By using balls of same volume. Okay, he used balls of same volume and different different what, guys? Different density, which made which meant some were heavier than others. Okay, now what does this mean? um like some were heavier than others, but they were had the same volume and they were falling exactly the same. Okay, why? Because gravity does not depend on weight. It does not depend on mass. That's what I want you guys to get from this second question. Okay, so here we have a little problem that we're gonna solve together. Okay, so what I want you guys to do is I want you guys to see, here's the problem. I want you guys to be looking at question, like for example, you look at question one, you read it, and then you try to solve it, okay? And then you look at question two, and so on and so on. But every time between questions, between one and two, I want you guys to see how I solve them, okay? So um, I'm gonna read the problem. We throw the basketball up with a force of 520 newtons. Let's consider the basketball to be of NBA's official size, which would give it a weight of 0.62 kilograms. Remember, Earth's gravity is 9.80 meters per second square. Pause and try to solve the question by question. Try to solve question by question, then come back and compare with the answer. So question one, what's the ball's initial speed? Uh-huh. So, where were we? Um, I was telling you, right? We have to throw a basketball up with a force of 520 newtons and it has this weight. And we get asked, what's the ball's initial speed? Okay, so we have that we throw it with a 250 newtons force. Okay, so all we have to do here is basically all we have to do is basically mhm. So we got an initial force of 520, let's check, newtons. Now what does this mean? Each force produces a certain velocity, right? You guys remember that? Why? Because force equals mass times acceleration. Okay, but so we have mass times acceleration. So we have a mass. This is 0.62 kilograms, right, guys? And then we have the acceleration. Okay, equals what, guys? Velocity divided by time, or the change in velocity through the change of time. So what we're trying to find is v velocity, otherwise known as speed, with some direction. So we have that all we have to do is get mass. Okay. Actually no, we have to get force. Okay, so we get force divided by mass times time. Okay. hmm But now here we have run into a certain problem. How do we find this initial speed? Okay. Uh-huh. So hmm so we have 520 newtons. Okay, so we have that we have this other formula, okay guys, which is gonna tell us um, so when we're throwing it up, we can have this formula here, which is the final velocity formula, okay, here. Okay, so let's go do that one. So we have to go here, final velocity equals initial velocity, or VO, times t. I mean this one right here on top. Okay, plus gravity times time plus gravity times time. Now this can be a plus or minus depending on the situation. On the initial speed, we get that the final speed is going to be less than the initial speed. Why? Because we're throwing it up. So when we throw something up, we're losing velocity as we to this formula right here. Okay, where we have this. Okay, but here the problem, okay, is what's the value of t? Okay, so they're saying we start with an initial, we throw a basketball force with a force of 500 newtons. Okay, yes, but that doesn't help us much. Okay, why? Because we don't really have at when we get to 520 newtons. You see, we can just have a velocity without having some distance. Okay, because let's remember that velocity is distance or some time. Okay, so since they're not giving us the distance or time, we can't solve question one. Okay, so I'm just going to underline it. We can't solve a question one, but we can if we have gotten that. Okay, if only we got something differently. Like for example, if the problem, let's fix the problem and says we throw the basketball up with a force of after 0.1 seconds. Okay, now there we have something, right? Because we have that we're throwing it with a force of 520 newtons after zero point 0.1 seconds. Okay, so thanks to that, we can finally solve our problem. Okay, so after zero point 0.1 seconds, so we have the time is now. Let's use a different color. Okay, let's go with orange. So we have velocity equals 520 newtons, which is the force, divided by the mass of 0.62 kilograms times 0.1 seconds. And this should give you guys a velocity of, okay, so everybody get out your calculator and try to solve these. Okay, so we have a velocity of 83.87 meters per second. Now let's check that out dimensionally. Newtons are going to be kilograms times meter per second square. Okay, so we can take out this square with this s of seconds. It's kilograms with these kilograms. And what do we get, guys? Meters per second. Okay, good. That's why we get meters per second, and it matches with that velocity. So now we have the initial velocity. Now, what else does it say? The question 2 says, what's the speed of the ball once it reaches its highest altitude? Okay, so highest altitude. This time we need to look at our equations here and find one which has the highest altitude, or actually we can just go ahead and understand that its final velocity will be what, guys? Be 0. Okay, but what's the speed of the ball once it reaches its highest altitude? Then we have that the speed is actually not that good calling speed, because speed implies no direction, or direction that we're not considering. So it should be velocity. The velocity will be 0. And how much time does the ball take to reach its highest altitude? Okay, now that's a great question. So we can take final velocity. Okay, this equation. So we have to have this equation right here. Okay, so that equation right there can give us that Bf equals 0 equals 83.87 meters per second. Okay, and in this case, since we're talking about throwing the ball up, we get minus gravity time. Okay, so we get this equation, and if we rearrange things, we can get 83.87 meters per second equals gravity times time. And then we all remember what gravity is, right, guys? So it would be 83.87 meters per second, divided by 9.8 meters per second square. And that should give you guys something with seconds. And let's use our calculator, and we get 83.87 divided by 9.8, 8.56. So we get 8.56 seconds. Now we finally have that at this time we have the highest altitude. Now we can also ask what altitude, right, guys? And how do we calculate this thing? Well, easy. With this other equation, right? The one that has height, J. And we got that height or altitude or height equals J. Okay, so and that will equal to initial speed times time. So we have initial speed times time plus 1/2 g times time square. Okay, g times time square divided by 2. Okay, there you go. So let's make this a little bit cleaner. Okay, there you go. So now that we have it, we can find the height. Now that we know that the initial velocity so it's 8.6. No, actually it's 83. Initial velocity is 83. See, here it is. It should be VO. Okay, 83.87. Okay, so we have 83.87 meters per square, and we have times time, which would be 8.56 plus gravity, which would be 9.8 meter per second square. Okay, times, and see how long it's going. See, it's a long equation. Okay, it's 2 divided by 2, and finally we get our result. So first things we're gonna do is we're gonna do this multiplication over here. Okay. Actually, let's do this to make it a little clearer. Okay, so 83.87 times 8.56, and that would give us, okay, I'm just gonna put it here, 717.9272 plus the other thing. Okay, so the other thing would be this that we have right here. Okay, so we grab our calculator and we do 9.8 times 8.56 square, and that result we divide it by 2 and we get a 359.04. Okay, and once we're done with this, we can go ahead and get the actual value, which would give us a value of 176 times 96 meters. Okay, now what does this mean? What does this actually mean, guys? Okay, this can mean something. This would mean that we have a person that's throwing the ball up. That's actually a superhero, we could say, because we have very large force in very short amount of time. See, we had an initial, it got to this force in 0.1 seconds. Okay, so mhm. So yeah, um, that can only mean one thing: that this person's a superhero. Okay, so we have this, and we have that we have a superhero. Okay, guys. Here's the cape. Here's the legs and everything. Okay, so superhero. Okay, now what's the velocity go along because gravity? Now, where were we? Oh, so we were on question one. So we get all the way here.